So let's look at this game tree and let us recall the third Nash equilibria in which the wife went to boxing and the husband's strategy was always to go to boxing. So along the dashed line, we have a rational outcome if the wife goes to boxing. So if the wife goes to boxing, the husband observes and then goes to boxing, he will end up with a payoff of 2. And that is a rational outcome. But remember, the husband's strategy is to always go to boxing. So the husband will also go to boxing even if the wife goes to the ballet. But if he does that, then he will end up with a payoff of 0. That would be an irrational outcome. So the dashed line, which ends up in the rational outcome, is called the equilibrium path. And so everything else, the rest of the game tree, is off the equilibrium path. So there's a concept called subgame perfect equilibrium, which rules out irrational play. And it is only useful for sequential games. Now, subgame perfect equilibrium, or SPE, is a refinement of Nash equilibrium, which rules out empty threats by requiring strategies to be rational even for contingencies which do not arise in equilibrium, right? So something happens that is off the equilibrium path, but if you identify a subgame perfect equilibria for this subgame, just for the subgame, the strategy adopted would be rational. Okay, so let's look at a couple of definitions. The subgame is the part of the extensive form beginning with a decision node and including everything to the right of it. And a proper subgame is a subgame that starts at a decision node, not connected to another in an information set. So this would be clearer when we look at the diagram. So the simultaneous move game, so this is the old simultaneous move game. This has only one proper subgame, the whole game itself. And there are no other subgames other than the whole game, because at the beginning, the husband and wife share the same information set. But in a sequential game, when we remove the fence from the husband's decision nodes, there are 3 proper subgames. Always the whole game itself. You know, the whole game is always a subgame. So the whole game itself is a subgame. And there are 2 subgames which start at node 2, the husband's node. So this node and everything to the right of it, and this other node and everything to the right of it, right? So these are 2 subgames. So what is the definition of a subgame perfect equilibrium? It is a strategy profile, S1 star, S2 star, all the way up to Sn star, that constitutes a Nash equilibrium for every proper subgame. An SPE is always a Nash equilibrium. In a game tree, SPE can be found by means of backwards induction. So this is a tactic that you could use to figure out subgame perfect equilibrium. In it, we work backwards from the end of the game. So firstly, we identify all of the subgames at the end of the extensive form, and then we find all of the Nash equilibria of the subgames. Second, we replace the subgames with the actions and payoffs resulting from the Nash equilibria. And thirdly, we move up the game and repeat the whole process. So let's look at this situation. So this is the original Battle of the Sexes game. And node 1 is the wife, node 2 is the husband, and we are going to start at the end of the game. So let's look at the subgame starting from node 2. Think about the husband. When the wife chooses ballet, what action would the husband choose? He will also choose ballet and get a payoff of 1. rather than irrationally choosing boxing and getting a payoff of 0. So after the husband has chosen ballet, we ignore or get rid of boxing. Now, if the wife chose boxing, then the husband should rationally also choose boxing and get a payoff of 2, instead of irrationally choosing ballet and getting a payoff of 0. So when the wife chooses boxing, the husband should choose boxing as well. And we can then get rid of ballet or ignore ballet and replace node 2 here and node 2 here with the payoffs, the rational payoffs of the rational action. So 2, 1, that payoff will come over here. And 1, 2, that payoff would come over here. We would then have a reduced form game, which we see to the right. And now what will player 1 or the wife do? Player 1 or the wife would go to ballet in order to maximize her payoff. It will be 2. If she went to boxing instead, her payoff would have only been 1, but that would represent an irrational action. So the rational thing to do for the wife in this reduced form game is to go to ballet. So now we have identified the subgame perfect equilibrium for the whole game. And in it, the wife goes to ballet and the husband is also at ballet. The wife gets a payoff of 2 and the husband gets a payoff of 1. So we have identified one Nash equilibrium, which is rational. And subgame perfect equilibrium, combined, the concept of subgame perfect equilibrium combined with backwards induction allowed us to eliminate irrational strategies or irrational play along the game. Okay, now we can repeat this exercise. So you redraw the game tree with the husband at node 1 and the wife at node 2. Now remember to adjust the payoffs at the end. So if at node 1 the player is husband and at node 2 the player is wife, then these payoffs have to be adjusted because the first entry is always player 1's payoff. So if player 1 is the husband, your payoff would be 1, 2. And over here it would be 0, 0, 0, 0, and over here it would be 2, 1. So when you do that and you repeat the logic of backwards induction and subgame perfection, you should get a subgame perfect equilibrium for the whole game of boxing with a payoff of 2, 1. And once again, backwards induction allows you to jump straight to SPE by bypassing other non-rational play and other Nash equilibrium. Okay, so I'm going to stop the video here.